Hey everyone, and welcome. Today we're not just going to learn about some code, we're going to learn how to draft the digital blueprints for pretty much any piece of software you can think of. We're talking about C programming, so let's just dive right in.
And really, that's the whole game, isn't it? How do you tell a computer exactly what you want? You can't just give it a vague idea, like, hey, build a house. Nope. You have to give it a super precise, step-by-step blueprint where absolutely nothing is left to chance. And languages like C, well, that's how we write those instructions. So you might be asking, why start with C of all things? It's because C is the bedrock. It's the foundation. Things like your computer's operating system, the web browser you're using right now, massive databases, so much of the digital world we live in has C running deep in its DNA. Learning C is kind of like learning the fundamental rules of architecture before you go off and try to design a skyscraper. It's that important.
Okay, so every building project starts with one thing, right? Raw materials. In the world of programming, our materials are data, and we need a way to store it, to label it, so we know what's what. That's where variables and data types come into play. The easiest way to think about a variable is to picture a labeled bin on a construction site. You just give it a name, something like age or price, and then you pop your data inside. That way, later on, you can easily find it and use it. It sounds simple, and it is, but it's an incredibly powerful idea. But of course, you can't just throw everything into the same kind of bin. I mean, you wouldn't store sand and giant steel beams together, would you? It's the exact same idea in C. We use these things called data types, like int for whole numbers, float for your decimal numbers, and char for single letters, to tell the computer exactly what kind of material, what kind of data it's dealing with.
Okay, so we've got our materials, and they're all sorted out into their nicely labeled bins. Now what? Well, now we need the tools to actually do something with them. So, welcome to your programming toolbox. Let's talk about operators.
Operators, these are your hammers, your screwdrivers, your measuring tapes. They're just simple symbols that let you add stuff, compare things, and really manipulate your variables in any way you need. They are literally the action words of your digital blueprint. And you have this whole range of tools ready to go. You've got your arithmetic operators for all the basic math. You have relational operators for comparing values, to check if one thing is bigger than another. And you've even got logical operators to make more complex decisions. Now listen up, because this next part is a big one. This is something that trips up almost every single person when they're starting out. A single equals sign, equals, that's for assignment. Think of it as the act of putting the number 10 into a box that you've labeled X. But a double equal sign, equals, equals, that's for comparison. That's you peeking into the box and asking the question, hey, is the number 10 in here? Mixing those two up is a classic beginner mistake, so keep an eye out for it. So, we have our materials and our tools. Now we need the actual instructions on the blueprint that tell us the order to do things in. In programming, these are called control structures. This is where your program starts to get smart. Control structures are basically the brains of the whole operation. They let your code make decisions and react to different situations. So instead of just running straight from top to bottom, your program can now choose different paths based on the data it's looking at. The most basic instruction you'll use is the if-else statement. It's super simple. The program asks a question like, is the user older than 18? If the answer is true, it does one thing. Else, if the answer is false, it does something totally different. Just think of it as a fork in the road for your code to follow. And what if you need to do the same thing, say, 100 times? Imagine laying a row of 100 bricks. You're not going to write down the instruction, lay one brick 100 times, are you? No way! You use a loop. Loops are these amazing tools for automation that just tell the computer, hey, keep doing this thing over and over until I tell you to stop. So as our projects get bigger and more complex, we don't want to build every single little piece from scratch every time. We start using prefabricated parts. And in C, our prefabs are concepts like functions, arrays, and pointers. A function is kind of like designing a standard window frame. You design it once, get it perfect, give it a name like calculate area, and then you can pop that same window frame into your building wherever you need it, just by calling its name. It's all about being efficient and not repeating yourself. Now, among all the functions you can create, there is one that is the undisputed boss, the main function. Every single C program has to have one. Think of it as the front door to your digital building. When you tell the computer to run your program, it walks right through that main door and starts following instructions from there. And to build even more awesome structures, you'll need things like arrays, which are just a way to store a whole bunch of similar items together, like that neat row of bricks we were talking about. Strings are really just a special kind of array for holding text. And pointers? Well, pointers are a little more advanced, but just know they give you the super direct, low-level control over your computer's memory. Pretty cool stuff.
All right, we've covered the blueprint, the materials, the tools, the assembly instructions. But you know what? Theory can only take you so far. The only real way to become a builder is to, well, start building. So what do you say? Are you ready to get your hands dirty and actually write some code? Let's talk about exactly how you can get started, like right now. A fantastic place to start is a website called HackerRank. They have a whole section just for C programming. You can start with Hello World. That's the traditional first program every coder on the planet writes. Then you can move on to a challenge called Sum and Difference to practice with variables and those arithmetic operators we talked about. And after that, try the Functions in C challenge to build your very first reusable part. So there you have it. The fundamentals are yours. The toolbox is open. You have the blueprint right here in your hands. The only question left is, what amazing thing are you going to build first?